Okay, looking at question 3 from exercise 10F, I'm going to go through parts A and B in a lot of detail because that helps us with part C. It's fundamentally important that we understand part C because this is very typical of a pulley exam question, which I'm going to give you in the forthcoming weeks, probably next week definitely, so you become more familiar with it. Okay, let's read the question carefully. Two particles A and B have masses of m kilograms and 3 kilograms respectively, where m is greater than 3. Why have they told me that? Well, they've told me that because if this has a bigger mass, then the weight of this is bigger. Therefore, when it's released, this is going to drop and this is going to go up. If m was less than 3, then it would be going the other way. It seems like a small bit of information, but it's fundamentally important. The particles are connected by a light, inextensible string. That means as this one accelerates down, this one will be accelerating up at the same acceleration. Passes over a smooth, don't need to worry about friction, fixed, that's staying there, and pulley. Initially, A is at 2.5 meters above the ground. We've got that. The particles are released from rest. Okay, so they're giving me a piece of information there. With the string taut, that's important because as that one moves, that one's going to be moving as well straight away. If it wasn't taut, then that wouldn't be the case. Hanging over the string, which is of the string vertical as shown in the figure. After A has been descending for 1.25 seconds, it strikes the ground. Particle A reaches the ground before B has reached the pulley. Okay, there's quite a lot of information on there. So let's just have a think about why it's telling me this. Particle A reaches the ground before B has reached the pulley. It's saying that as this one goes up, as this one goes down, this one's going to be going up. But not to the point where as this one goes up, it smacks into the pulley. So when this one has descended and hit the ground, this particle here, B, hasn't yet hit the pulley. That's important. Okay, first part. Show that the acceleration of B as it ascends is 3.2 meters per second. The first thing I'm always going to advise you to do with this one is label everything that is going on in this diagram. As we discussed, because the mass of this is greater than this, it will be accelerating down this way. This, because they are connected, is going to be accelerating upwards at exactly the same acceleration. This acceleration down is exactly the same as the acceleration up. Okay, think about other things. This has a mass of 3 kilograms. Therefore, its weight is going to be 3 mg. Sorry, not 3 mg. I keep doing that. Just mass, which is 3, times gravity, which is g. So 3g. This one is m. Therefore, this is going to be mg. Something is being pulled here, so tension exists in the string. Yeah, there will be a tension acting up here. That's the thing that's essentially pulling this particle up, and that will be offset by another tension here, which is acting on the pulley. There will be a tension here, which is the one produced by particle B, and another one here. Now, sometimes these ones aren't even labeled, these ones here. But I have seen previously, and I'll give you exam questions later based on ones like this, they'll say, what force is acting on the pulley? And you have to be thinking about that tension. Yeah? Okay. Part A. Show that the acceleration of B as it ascends, is 3.2 meters per second. Okay. Show that the acceleration of B as it ascends. Okay. Well, if I think about it, the acceleration of B is going to be exactly the same as the acceleration of A anyway, isn't it? So, and because I'm given more information about A, i.e. how long it takes to strike the ground and the distance to the ground, if I can work out the acceleration of A as it descends, it will be exactly the same as the acceleration of B as it ascends. Okay, part A. I know that the acceleration is going to be constant, so I'll list my suvat. If I call down positive, I'm going to say that it's moved 2.5 meters. It told me that it was released from rest. I know the initial velocity is 0. V I don't know. It's obviously not going to be 0. We've had that conversation before. It will be the moment where it's infinitesimally close just before it hits the ground. I don't know what the final velocity will be. The acceleration, I don't know yet. That's what I'm going to hope to work out. And then t, I'm told it takes 1.25 seconds before it hits the ground. So that will be 1.25. Right, what things have I got? I have S, U, I want A, and I have T. Nothing to do with V. The Suvat formula I want is S equals UT plus a half AT squared. Fill in what I've got. I know that S equals 2.5. I know the initial velocity is 0, therefore 0 times t is just going to get rid of this bit. Then I've got half A, which I don't know, times t, which is 1.25. That's then all being squared. Rearrange, and you should work out that the acceleration, that's a very small a, is equal to 3.2 meters per second squared. Okay. That's part A done. Right, part B coming up.